So when I went through school, we always included this reaction together with the halogenation, the nitration and the Friedel Crafts. Not sure why it's not in the WJEC syllabus. Maybe the mechanism a little bit funny or whatever. But anyway, you can make this sulfonated benzene right here by just reacting benzene with so-called fuming sulfuric acid, which contains an elevated amount of SO3. So we want to write down the mechanism, and rather than have you come up with a mechanism from scratch, I gave you the step-by-step description. So all you had to do was fill in the structures for it. Now I should point out before I start that there is, those of you who would have read the molecular structures extension material know that there's debate in the chemical education literature about the right way to draw Lewis structures. There are those who believe that formal charges are paramount importance. There are those who believe the octet rule is of great importance. And so this leads to debate about whether or not you put double bonds, single bonds, resonated bonds, again for those of you who watch the extension material. I don't really care. So what I'm going to be doing here, what I did in actually the video, was I'm just drawing the important electron movement. I'm not worried about whether an extra bond here or there is supposed to be a single or a double bond in compounds that don't really matter. Now, what I mean by that is here's sulfuric acid. There are those who would put two double bonds there. Doesn't matter. Okay, what's important here is you've got this O and this H, because this H is going to be an acidic H, is going to do some protonating of SO3. And again, some people, a lot of organic chemists, would draw SO3 with 3 double bonds to the sulfur. I personally draw it as a resonance of double and single bonds, but here it doesn't really matter. What matters is that oxygen's got a lone pair of electrons, which it donates towards the H+. The H+ protonates the SO3, however you feel like putting it. So we get hydrogen sulfate. Again, draw its structure as you see fit. What's important is it's got hydrogen and it's got a minus sign, and it is the conjugate base of sulfuric acid. And now we have this nice protonated species. Now again, oxygen does not like being formally positive, so therefore it makes it even more electronegative, so it's really sucking electrons away from the sulfur, thus making that sulfur considerably slightly positive, and thus a lovely electrophile. So now that sulfur serves as the electrophilic atom to make the intermediate. Here is our benzene, usual thing you've seen before. Here's the intermediate flying in. Electrons come from the pi electrons here, going to the sulfur there, making this intermediate here. Again, there would be those who would sort of place various arrows within this, making it go around and so forth. Really doesn't make much odds. Okay, now the final step, hydrogen sulfate, which we made up here, abstracts that last proton, leaving behind our desired product, and of course the sulfuric acid catalyst has been regenerated again. Okay, what's not important here are the extra bonds and so forth, and lots of lone pairs that I haven't drawn in. What's not terribly important is the role of the proton here. I've drawn it as one fairly directed mechanism. Other people would do all kinds of messing around with it. Really what's important is how we're going to get this electrophilic sulfur. Well, we protonate one of the oxygens, thus making the sulfur more positive, and then we're going to have the attack of the pi electrons on that sulfur, making the carbon sulfur bond.